Hello guys, Assalamu alaikum. Welcome back to Sulaiman Educational Channel. Today in this video we are going to discuss about problem solving and design. We are going to discuss about computer system, top-down design, structure diagram, library routine, subroutine, algorithm, test data. In this part, we will discuss what a computer system is. A computer system is made up of software, data, hardware, communications, and people. Each computer system can be divided up into a set of subsystems. Each subsystem can be further divided into subsystems and so on until each subsystem just perform a single task. So a single software is made up of many subsystems which perform different tasks. For example, in Microsoft Word, we can add text, pictures, tables, etc. Pictures can be further divided into picture style, picture border, picture effect, and so on. So we can see that a single software is made up of many subsystems. In this part, we will discuss about top-down design. Top-down design is the breaking down of a computer system into a set of subsystems. As we have studied earlier, that system is made up of many subsystems working together. We then break each subsystem down into a set of smaller subsystems, and we can continue to break the subsystem further until each subsystem just perform a single action. In order to show top-down design in a diagrammatic form, structure diagrams can be used. A structure diagram shows the design of a computer system in a hierarchical way, with each level giving a more detailed breakdown of the system into subsystems. Let's look at an example of structure diagram. In this diagram, alarm app is divided into set alarm, check time, and sound alarm. Set alarm is further divided into set time and turn on off alarm. Sound alarm is divided into play sound for 2 minutes, check off snooze, and reset clear alarm. This is an example of structure diagram. From the diagram, it is clear that it is organized into hierarchical way. The breakdown into subsystems can also be seen clearly. Now let's look at another example of structured diagram. In this diagram, smartphone is divided into three subsystems. The first one is input-output, the second one is file handling, and the third one is transmission. Input-output is further divided into two subsystems, input and output. File handling is further divided into two subsystems, read data and write data. Transmission is further divided into two subsystems, incoming and outgoing. Now in this part we will discuss about library routine. A library routine is a set of programming instructions for a given task that is already available for use. It is pre-tested and usually perform a task that is frequently required. For example, the square function. The purpose of the square function is to take a number and multiply it by itself and produce the output. So the function is created and kept in a library and used in all the software. We do not have to write the code again and again. Many functions or routines are created and a library has been generated for us to use and save our time in writing the codes. It also makes the program smaller in size because the number of lines have been reduced. Now in this part we will discuss about subroutine. A subroutine is a set of programming instruction for a given task that forms a subsystem, not the whole system. Subroutines written in high-level language are called procedure or functions depending on how they are used. As we have mentioned earlier, the square function, in some programming languages it might be called procedures. Now we will discuss what an algorithm is. Algorithm is a step-by-step procedure to perform a task. For example, making of tea, driving a car, using ATM machines, and so on. There are two types of algorithm. One is the pseudocode and the other is the flowchart. Now in this part, we will discuss about pseudocode. Pseudocode is a simple method of showing an algorithm using English-like words and mathematical operators that are set out to look like a program. So in a pseudocode, you will write the steps and procedures in English and also use mathematical operators like plus, minus, division. You can also use comparison operator like greater than, less than, equal to, and not. Now let's look at an example of pseudocode. Repeat, wait till 10 seconds, get time, until time is equal to alarm time, sound alarm. Here you can see that it is written in normal English. Repeat, wait till 10 seconds clearly shows that it will wait for 10 seconds, after which it will get time and then compare the time with the alarm time set. If the value is true, then it will sound the alarm. If the value is false, it will continue the process of waiting for 10 seconds and get time and then compare the time. Now in this part, we will discuss about flowchart. A flowchart shows diagrammatically the steps required for a task, subsystem, and the order that they are to be performed. These steps together with the order are called an algorithm. Flowcharts are an effective way to communicate the algorithm that shows how the system or subsystem works. Now let's see an example of flowchart. The flowchart is designed for the same algorithm that we have discussed in pseudocode. In pseudocode it is in normal English, but in flowchart special symbols are used to represent the action. Now in this part, we will discuss the symbol for flowchart. The oval shape shows start and end of a program. The parallelogram is used for input and output. The rhombus shape is used for decision. The decision value can be true or false, so there are two paths, one for true or yes and the other for false or no. The rectangle shape is used to show processing. Now in this part, we are going to discuss about test data. In order to determine whether a solution is working as it should, it needs to be tested. Usually before a whole system is tested, each subsystem is tested separately. For example, sum equals to a plus b is a statement. So we know after adding 15 and 20, the answer should be 35. If the answer is incorrect, then there is an error. It might be an error in the equation or program. Now in this part, we will discuss about the types of test data. The first type is the normal data. It is the data in which the result or output are expected. For explaining the test data, we are going to take the example of test mark. The test mark is of 20 marks. So the normal data are the numbers from 1 to 19. The second type is the erroneous data. In this, the value should be rejected. For example, 21 and minus 5 are erroneous test data because the test marks cannot be negative and cannot be greater than 20. Erroneous data is also called as abnormal test data. The third type of test data is the extreme data. Extreme data are the largest and the smallest value that normal data can take. When I mentioned about normal data, I mentioned numbers from 1 to 19. I didn't mention 0 and 20. 0 is the smallest value that a normal data can take, so it is extreme data. Similarly, 20 is the largest value a normal data can take, so it is also extreme data. The last type of test data is the boundary data. At each boundary, two values are required. One value is accepted and the other value is rejected. So in lower boundary, 0 and -1, 0 is accepted and -1 is rejected. In upper boundary, 20 and 21, 20 is accepted and 21 is rejected. This is the end of the video. If you haven't subscribed the channel, then do so by clicking the button. Don't forget to press the bell icon to get notification of the latest videos uploaded on our channel. Don't forget to like, comment and share our videos. You can also follow us on our Facebook page. The link is given in the comment section. We will meet again soon with a new video. Thanks for watching. Take care and Allah Hafiz.